A mineral is naturally occurring solid chemical substance which is formed through biochemical processes. Minerals are found in rocks on the surface of the earth or beneath it in the form of compounds. They have a definite chemical composition comprising one or more elements. They can be identified by their physical and chemical properties. In this chapter, we will study the following concepts: classification of minerals, conservation of minerals. A mineral is naturally occurring solid chemical substance which is formed through biochemical processes. Minerals are found in rocks on the surface of the earth or beneath it in the form of compounds. They have a definite chemical composition comprising one or more elements. They can be identified by their physical and chemical properties. In this chapter, we will study the following concepts: classification of minerals, conservation of minerals. Minerals and energy resources. Minerals and energy resources. Minerals are found in rocks on the surface of the earth or beneath it in the form of compounds. They have a definite chemical composition comprising of one or more elements. They can be identified by their physical and chemical properties. A mineral from which a metal is obtained is called an ore. Importance of minerals. Minerals are naturally occurring inorganic substances. Everything found on the Earth's crust is made of minerals. They are an indispensable part of our daily life. They have the following economic uses. Everything we use, including the food we eat and the water we drink, is made of minerals. The economic development of people or nations can be vastly accelerated by the presence of valuable minerals. Minerals also make our life comfortable, like the fuels used in the transport vehicles. Human beings have used minerals for their livelihoods, decorations, festivities, and ceremonial rites. Minerals also make biological processes possible on Earth. In our daily consumption, we use just 0.3% of total nutrient intake. Despite its minuscule quantity, it is so important from a nutritional and energy-giving point of view that without this energy input, we would find ourselves unable to utilize the remaining 99.7% of the foodstuffs. Rocks containing minerals. The compacted substances that comprise the Earth's crust are called rocks. In geological terms, rocks are the naturally formed aggregate of mineral particles. It is the minerals that impart their texture, color, shape, hardness or softness to rocks. Over 3,000 minerals have been identified so far. Only a few are abundantly found in the Earth's crust. Rocks are aggregates of minerals. Geologists use these properties to classify minerals in rocks. Classification of minerals. Minerals: metallic, non-metallic, energy minerals. Ferrous, containing iron. Example: iron ore, manganese, nickel, cobalt, etc. Non-ferrous. Example: copper, lead, tin, bauxite, etc. Precious. Example: gold, silver, platinum, etc. Non-metallic. Example: mica, salt, potash, sulfur, granite, limestone, marble, sandstone, etc. Energy minerals: coal, petroleum, and natural gas. Metallic minerals, non-metallic minerals. Mode of occurrence of minerals. Veins and lodes. The cracks and fissures in the Earth's crust are generally known as veins and lodes. A lode is a mineral vein or a network of veins in a rock. On account of convection currents rising in the interior of the Earth, many minerals have been deposited in these veins. The metallic minerals are distinguished from other types of minerals in these veins and lodes. Metals are strong and hard, and these features are not found in other types of minerals. Beds and layers. The sedimentary rocks containing minerals occur in beds and layers. In the process of formation of sedimentary rocks, minerals are generally deposited in horizontal strata. This concentration is mainly responsible for extraction of minerals from these rocks. Metallic minerals generally occur in rocks in the interior of the earth than on the ground. Certain minerals found in sedimentary rocks are transformed as a result of pressure and heat over a long period of time. Residual mass. Most surface rocks undergo transformation on account of weathering. The weathering materials left behind as residual mass may contain ores. Bauxite ore or aluminium ore is formed in this way. Alluvial deposits. The river sediments may also contain minerals. Since the river originates from mountains or hills, it carries with it these sediments called placer deposits, generally consisting of sand and gravel containing valuable minerals. Diffusion. Diffusion of minerals refers to the process of spreading out of minerals through ocean waves and currents. Though it occurs widely, the process of mixing is very slow but of great economic significance. The ocean beds have rich deposits of many types of minerals which have been diffused from the surface. Mining of minerals. Quarrying. The excavation of minerals on the surface of the earth is called quarrying. It is done usually for extraction of stones, pebbles, and marbles for building and construction activity. Open pit mining. It is also known as open cast mining. In USA, open cut or strip mining. This type of method is used for the mineral strata being exposed on the surface when overlaying strata has been removed by human action or natural forces. The open cast mining is often worked mechanically. Mining. The underground deep excavation of minerals is generally termed as mining. Most fossil fuels are obtained in this way. The underground working or mining is now most common as the surface deposits have almost been exhausted. Distribution of minerals in India. India is sufficiently rich in mineral resources. They provide the country with the necessary base for industrial development. India has the potential to become an industrial power on its own because of its mineral resources. The distribution of minerals in India is uneven. There are 4 chief regions for this. Northeastern part of peninsula including Chota Nagpur Plateau. In central region of Madhya Pradesh, Maharashtra and Chhattisgarh. The southern plateau, Rajasthan. Generalized distribution. Jharkhand 29.5%, Madhya Pradesh 16.5%, West Bengal 10.7%. The metallic minerals are divided into 2 categories. Ferrous. Ferrous minerals contain iron. These include iron ore, manganese ore, chromite, tungsten, cobalt, and nickel. Non-ferrous. Non-ferrous metals which do not contain iron include gold, copper, silver, lead, magnesium, bauxite, and tin. Ferrous minerals. Iron ore. Iron is the most useful of all metals. It has strength, hardness, and magnetic properties. Iron has become the basis of modern industrialization. It has revolutionized modern means of land, air, and water transport. India is rich both in quality and quantity of iron ore deposits and ranks 4th in reserves and 5th in the production of iron ore. Its share in the world production is 4.1% after China, Brazil, Australia, and Russia. Production. Most of the high-grade iron ore, magnetite deposits are in Bailadila, of Chhattisgarh, Bellary Hospet area of Karnataka state as well as in Jharkhand state. These deposits are the world's richest and the largest deposits but are limited resource. Distribution of iron ore deposits. Magnetite and hematite reserves are found in many states, but Jharkhand and Odisha produce about 75% of total production of this iron ore in India. This is called Iron Ore Belt of India. Major steel plants of India are located in this region. Jharkhand. Naumundi and Gua mines in Singhbhum and Hazaribagh districts have hematite iron ore mines. Odisha. Keonjhar, Mayurbhanj and Bonai mines have hematite iron ore deposits. Chhattisgarh. Dhali Rajhara Hills, Durg and Bailadila, Bastar have abundant amount of hematite deposits. This range of hills comprises of 14 deposits of super high-grade hematite iron ore. It is used for steel making and exported mainly to Japan and South Korea from Visakhapatnam port. Tamil Nadu and Karnataka. Salem and Madurai belt in Tamil Nadu and Chitradurga, Chikmagalur and Tumkur belt in Karnataka have major steel plants of South India. Production. Most of the high-grade iron ore, magnetite deposits are in Bailadila of Chhattisgarh, Bellary Hospet area of Karnataka state as well as in Jharkhand state. These deposits are the world's richest and the largest deposits but are limited resource. Manganese. Manganese is ferroalloy metal. It is used in the production of steel and preparing alloys. Nearly 10 kg of manganese is required to manufacture 1 ton of steel. It is also used in the manufacture of bleaching powder, insecticides and paints. Areas of production. In India, manganese is found in areas as given below and is obtained from igneous rocks. The main reserves are located in Orissa, followed by Karnataka and Madhya Pradesh. Other areas are Nagpur and Bandra districts, Maharashtra. Orissa has mines in Gangpur, Kalahandi Koraput, Bonai and Mayurbhanj regions. Karnataka has reserves in Chitradurga Shimoga region, Chikmagalur, Belgaum and Dharwar districts. Visakhapatnam in Andhra Pradesh, Singhbhum in Jharkhand, Udaipur in Rajasthan. Non-ferrous minerals. India is deficient in copper and has to depend on foreign supplies. The total reserves are estimated at 7,125 lakh tons. On an average, the annual production of copper concentrate is nearly 1.5 lakh tons. The Balaghat mines in Madhya Pradesh produce 52% of India's copper. Areas of production. Consular Plateau. About 90% of these reserves are concentrated in Jharkhand, Andhra Pradesh, Rajasthan, Karnataka and Madhya Pradesh. Madhya Pradesh, Balaghat. Jharkhand, Singhbhum district, Mosabani, Rakha, Dhobani mines. Rajasthan, Jhunjhunu, Khetri mines and Kohdariba in Alwar. Other areas. Khamman, Andhra, Hassan and Chitradurga, Karnataka, Sikkim, Kullu, Himachal Pradesh. Non-ferrous minerals. India is deficient in copper and has to depend on foreign supplies. The total reserves are estimated at 7,125 lakh tons. On an average, the annual production of copper concentrate is nearly 1.5 lakh tons. The Balaghat mines in Madhya Pradesh produce 52% of India's copper. Bauxite. Aluminium is obtained from bauxite. The deposits of this valuable ore in India are widely distributed. India has 30,750 lakh tons of total recoverable reserves of bauxite. About 88% of recoverable reserves are of metallurgical grade. On an average, the total annual production of bauxite is 110 lakh tons. Areas of production. India has vast reserves of bauxite. Jharkhand,
Odisha,
Andhra Pradesh, Bihar, Gujarat and Madhya Pradesh are the major producers of bauxite.
Odisha,
Odisha is the largest bauxite producing state in India with 36.8% of total production in 2000-2001. Panchpatmali in Korapur district is the site of the most important bauxite deposits in the state. Jharkhand, Palamu, Lohardaga and Ranchi. Gujarat, Bhavnagar and Kaira. Madhya Pradesh, Surguja, Bilaspur, Kanti and Raigarh, Chhattisgarh. Other areas: Kolhapur, Maharashtra, Belgaum, Karnataka, Nilgiris, Tamil Nadu, Sambalpur,
Odisha
and Goa. Mica production. India is the largest producer of mica, accounting for 60% of mica trade in the world. Average annual production of mica is about 2,000 tons. It is transparent mineral deposited in layers. Its ability to withstand high temperature along with its transparency makes it ideal for a host of industrial applications. Three types of mica are found in India: white mica, amber mica, black mica.
Rock minerals. Limestone is found in association with rocks composed of magnesium carbonates and calcium carbonates or calcium. It is found in sedimentary rocks of mainly geological formations. Limestone is the basic raw material for the cement industry and vital for smelting iron ore in the blast furnace.
Hazards of mining. Mining is a hazardous occupation. It also has a considerable impact on our natural environment as well as the health of the people. If you visit some mining areas in Jharkhand, Karnataka or other belts, you will come to learn the hazards associated with mining. The risks on account of mining accidents such as collapsing of mining roofs, inundation of mines, fires, collapsing of shafts, cave-ins, and other risks are common occurrences in mines. The mining activity also contaminates water resources, displaces huge hills, and there are no proper arrangements for dumping of mining residues and wastes. It leads to environmental and soil degradation, pollution of air and water, change in the course of streams and rivers, and other such hazards. Mining was previously called the robber industry. Now it is becoming a killer industry, consequent upon extensive damage to our environment.